Hi, hello everyone. Welcome back to my YouTube channel. Today we are going to explore about a topic which comes under the subject chemistry, which is known as electrode system. As you all know, myself Kaveshri studying in Sri Venkateswara College of Engineering. Today I am going to discuss about the electrode system, which comes under the subject called applied chemistry for computer science and engineering. Electrode system. Electrode system contents. First we are going to study about the introduction part of electrode system, and next electrochemical cell, what are the types of electrochemical cells, and next we are going to discuss the important reactions which occurs at electrochemical cells, and construction and working of galvanic cell. Next, the types of electrodes, and at the last, reference electrodes. First is introduction. Let us study what is meant by electrochemistry. As the name suggests, it is a relationship between the electric and chemical phenomena. Next is electrode. An electrode is a conductor which is made to contact with the non-metallic part of the circuit. It serves as a point where the current enters and leaves the electrolyte. Electrodes are very essential components in batteries, electroplating, electrolysis, welding and medical devices. EMF of a cell. The full form of EMF is given as electromotive force. The electromotive force refers to the maximum potential difference between two electrodes like anode and cathode inside the cell. The mathematical representation of a EMF is given like E cell is equal to E cathode minus E anode. Let us study the definition of single electropotential. The definition is given as the potential of a single electrode within a off cell is known as single electropotential. The standard electropotential should satisfy the standard conditions. Under standard conditions, the standard electropotential occurs in an electrochemical cell. Let us say the temperature should be 298 Kelvin and pressure should be 1 atm and concentration should be 1 molar. The E0 cell represents the standard electrode potential. Let us study the important topic under electrode system. First is electrochemical cells. Definition of electrochemical cell is given as it is a device which converts the electrical energy into the chemical energy, and it also converts the chemical energy into the electrical energy. Basically, there are only two types of electrochemical cell, but they consider as a three types of electrochemical cell. First is a galvanic cell. A galvanic cell is a device in which it converts the chemical energy into electrical energy. Example, a dry cell. Second type is an electrolytic cell. It is a device which converts the electrical energy into the chemical energy. Example, Nelson cell and Down cell. Third type of a cell is a concentration cell. The concentration cell is a cell in an electrochemical cell in which electrode materials and electrolytes of two off cells are composed of same metals, but the concentration of two electrodes or electrolytes are different. Example, copper concentration cell. Let us study important reactions occurs in the electrochemical cell. First is oxidation reaction. This reaction takes place by the loss of electrons, and second is reduction reaction. This reaction takes place by the gain of electrons. Let us see the example how the loss of electrons and gain of electrons takes place in the electrochemical cell. Here is a best example. Under the electrochemical cell, there are two separate half cells, and this is an anode and this is an cathode. Under anode, the oxidation reactions takes place, and under cathode, the reduction reactions takes place. As you can see, there is a zinc electrode and copper electrode which are dipped inside the zinc sulfate and copper sulfate. Here in the zinc electron, there is loss of 2 electrons which is gained by the copper electrode to form a metal called Cu. Let us study the construction of galvanic cell. A Daniell cell is an example of a galvanic cell. In a galvanic cell, it consists of two containers. In one container, a zinc electrode is dipped inside a zinc sulfate solution, and other container consists of a copper sulfate and copper electrode is dipped inside this solution. These two electrodes are internally connected by a salt bridge and externally connected by a metallic wire to the voltmeter. In this galvanic cell, there will be taking place of redox reactions like oxidation and reduction reactions. Let us study the working of galvanic cell. As we studied earlier, zinc electrode is dipped inside the zinc sulfate solution and copper electrode is dipped inside the copper sulfate solution. These both are internally connected by the salt bridge and they are externally connected by the voltmeter. As we know, under this zinc electrode, the zinc undergoes inside this zinc sulfate solution to form Zn2 plus ions by the liberation of 2 electrodes. Under zinc electrode, the oxidation reaction is taking place and the zinc electrode acts as an anode. Under copper electrode, the reduction of copper ions are taking place by the decomposition of a metallic copper on a copper rod by gaining of the electrons. At copper electron, reduction reaction is taking place and it acts as a cathode. Let us see the reactions which occurs at anode. When zinc is reacted, Zn2 plus is formed with the liberation of 2 electrons, and when a copper ions is reacted with the 2 electrons to form copper, and the net reaction can be stated as or given as when zinc plus copper is reacted, the Zn2 plus and copper is formed. The net reaction shows that electricity is generated by the moving of electrons from zinc to cathode. Let us study types of electrode. First is metal-metal ion electrode. A metal is in contact with a solution containing its own ions. Example, zinc electrode which is in contact with the zinc sulfate solution which we have seen in a galvanic cell. Second is metal-metal salt ion electrode where a metal is in contact with a solution containing the anion of the salt. Example, calomel electrode. Third is a gas electrode where a gas in contact with the inert metal dipped in an ionic solution of a gas molecules. Example, H2 electrode or a She electrode. Fourth is an amalgam electrode where a metal dissolved in mercury is in contact with a metal salt solution. Example, zinc in a mercury is in contact with the zinc sulfate solution. Fifth is a redox electrode where an inert metal is in contact with a solution containing metal ions of a different oxidation state. Example, platinum is in contact with the iron. Sixth is an ion selective electrode. Electrodes which has the ability to select its own ions. Example, gas electrode and liquid membrane electrode. Let us study the last topic of this electrode system, which is reference electrodes. Reference electrodes are the electrodes whose potential already are known to us, or the reference electrodes are the electrodes with known potential, and with its reference these electrodes we can determine the potential of the another electrodes. Reference electrodes has two types of electrodes. First is a primary reference electrodes. These are the electrode used to measure the potential of the other electrode, whose potential is an arbitrary or taken as zero at all temperature. Example, standard hydrogen electrode or She electrode. Second is secondary reference electrode. These are the electrodes used to measure the electrode potential of the other metals whose potential with respect to She, or primary reference electrode, which is known already to us. Example, calomel electrode or silver chloride electrode. Thank you for everyone watching my video.